Hello all, welcome to the Wi-Fi monitoring course for red and blue teams at Pentester Academy. Now in this video we will look at access point based monitoring. Now why access points? Simply because when we go into N and AC, there are a lot of complications as far as creating a reliable Wi-Fi monitor is concerned. This is really where having dedicated hardware capable of doing a lot of the advanced stuff like 3 to 4 spatial streams, beamforming and all of that allows a wireless pen tester to have more control over both monitoring as well as kind of pen testing the same network. So the access point I'm going to use is part of the Ubiquity access point series. I'm going to pick up the one which is the cheapest so that you can replicate this later. And this is the UAP AC Lite, which is just shy of $100. There are other options available as well, which are more expensive, and you can explore them if you like. The process to set them up is exactly the same as the AC Lite. Now, what is the key difference between the AC Lite, the LR, which is long range, the Pro HD, etc.? If you notice, first of all, is if you look at radios and antenna, you will see that the AC Lite is a 2x2, while the LR is 3x3 and HD is 4x4. So we can clearly see that the number of spatial streams we can do differs, and at the very same time, as expected, the speed on both 2.4 and 5 gigahertz differs as well. Now, the only downside of using access points are the fact that these use a lot more power than those USB keys which we have. For example, the AC Lite actually takes in around 24 volts. As you can imagine, that's probably a lot of power to be carrying around in a backpack, and you probably will be connected to a power outlet when you use these devices. Okay, so here is the AC Lite. Now, once you unbox it, let me take this out of the box. Pretty bad at doing this, always end up going ahead and making a mess. Okay, so once we open the box, apart from the manuals and all of that, you have the really cute looking UAP AC Lite. Can remove the back cover. This is typically for ceiling mount, and you'll find one Ethernet one Ethernet port available. This is all we have to connect to this AP. Now if you looked at the box further, you would find two essential things. One of them is a PoE injector, and the other, of course, is the power cord. Now, the PoE injector has two ports. One of them is the PoE port and the other is the LAN port. So what we are going to do is connect the PoE port to the AC Lite access point and then connect the LAN port to the Ethernet port of our laptop. So I'm just going to pause the video briefly while I get all of that set up. Okay, so I've just powered on the access point and I've connected it to my Ethernet using the PoE injector. So let's wait for it to come up. Now, keep in mind that this is really a ceiling mount AP, and ideally, when it is actually sold on Amazon or any other place, you end up wanting to use its controller software through which you can configure it. Now, there are options where you can probably also maybe get cloud access and all of the latest fun stuff which we've seen with access points. Now, for our purposes, we do not require the controller software. So something very important, do not make the mistake of downloading the controller software and going ahead and configuring this access point. Because once you use the controller software, it'll go ahead and provision this AP, and when it does that, it actually sends through a massive number of configurations. To undo all of that is going to be a huge pain. So once you buy this, take it out of the box, just connect it to your PC. Do not use the little manual in there. You might be tempted. Do not use that. Okay, now the good news is that we can SSH into this access point, right? We don't need the web-based GUI at all. And what we would find later is this is nothing but an OpenWRT Linux system. Now, unfortunately, it's a very stripped down OpenWRT system. And we really have a lot of space constraints on it. But the good news is that later in one of the videos, I'll show you how to go ahead and pretty much load OpenWRT on it and do interesting things. Now in this video, we are going to work with the manufacturer's firmware on it. I am not going to replace that or mod that with my own OpenWRT system, okay? The Wi-Fi drivers in there are the Mad Wi-Fi NG drivers. And when you want to SSH into it, what really happens is that when you connect it to the laptop's Ethernet, the DHCP request on the AP times out. So the AP tries to get a DHCP based IP address. When that times out, it automatically sets itself up on a static IP address, which is 192.168.1.20 for every single Ubiquiti AP. Whether you are using the AC Lite, the Pro, the HD, the EDU, the IP address is the same, right? So all I've done is I'm just waiting for it to time out DHCP and settle down. And once that happens, we can SSH into it. The username for SSH is UBNT and the password is UBNT as well. Okay, so what I've done is I've gone ahead and brought up my Kali VM. Now, let me quickly check. I'm just going to go ahead and pause the video if my access point has come up and if it's ready to use. Okay, so I'm going to go inside my Kali VM. Now, what I have done is that the VM is bridged to the Ethernet interface. And I'm just going to go ahead and give the Ethernet interface an IP address in the same range as 1.20. So once we do that, I should be able to ping 1.20, which is my Ubiquiti AC Lite router. There we go. Now let me SSH into it. As I mentioned, the username is UBNT. I've used the same IP before, so I'm just going to quickly remove my known hosts file. Okay, so now let's connect to it. The password is UBNT as well, and there we go. So we land into a BusyBox shell. If you do not know what BusyBox is, please have a look at the Pentester Academy Hacker Gadget series, where I talk about this in great detail. Okay, so let's look at all the commands available on the Ubiquiti router. So if I hit tab twice, I get a massive list of all the commands, as you can see. Now, keep in mind that all of these are really the built-in commands on the Ubiquiti system. The Ubiquiti system itself is really OpenWRT. Now, when I look at this, I'm really looking for Wi-Fi utilities which we can use to our advantage. So I immediately see a WLAN config tool right here. And I also see a Wi-Fi try, Wi-Fi tool. We also have the usual suspects, which is WPA CLI and WPA supplicant, as you can clearly see. Great. Now, when I see WLAN config, that actually makes me quite happy, because this means that I should be able to configure interfaces. So what is the intent now? The manufacturer created this as an access point, right? A dual band AP, which has two radios, one on 2.4 gigahertz and the other on 5. Now he wants this to work as an AP, but we want it to work as a monitoring platform. So if I look at the list of interfaces right now, the Wi-Fi interfaces in particular, what I would find is that both of them might be in AP mode, or a mix of AP and managed mode, which is client mode. So let's have a look at that. The iwconfig command is available. Fantastic. So I can clearly see that I have an AT1 and I also have an AT0 here. AT1 seems to be in managed mode, while AT0 seems to be in monitor mode, master mode. And of course, these are built on top of Wi-Fi 1 and Wi-Fi 0. Okay. So AT1 and AT0 is what the manufacturer created by default on these systems, right? So what I would like to do is I want these two interfaces to basically vanish, and I'd like to replace them with monitor mode interfaces, right? So how do we do that? Now, if we run the WLAN config command, what you would find is that this command allows us to create basically virtual adapters on top of the real physical adapter and put that into monitor mode. So the first step, of course, as we can clearly see, is WLAN AT0 destroy, right? WLAN config ATX destroy. So we are going to use this first to destroy both the AT0 and AT1 interfaces created by the manufacturer. Now, before I do that, it's always a good idea to bring both these interfaces down. AT0 down. And once we do that, I should be able to run WLAN config AT0 destroy, and then similarly AT1 destroy. Now once I do that and run iwconfig again, if you notice, I don't have AT0 and AT1 anymore. Fantastic. So this is half the job done. Now, well, we don't have any interfaces to do anything with at this stage. So what I want is a monitor mode interface both on 2.4 and 5. So to do that, again, I'm going to use the WLAN config utility. And I'm going to say, so without arguments, we see what it has, WLAN config. I'm going to create a mon0 and say create WLAN dev on top of Wi-Fi 0, and the WLAN mode for this interface should be monitor. Okay. And similarly, on top of Wi-Fi 1, I'd like to see mon1. There we go. Now if I do an iwconfig, I would actually find a mon0 interface and a mon1 interface. The mon1 is on 5 gigahertz, while mon0 is on 2.4 gigahertz. Fantastic. Now let's go ahead and bring both of these interfaces up. So I'm going to do an ifconfig ifconfig mon0 up, and then an ifconfig mon1 up. Now, as you can clearly see, this allows us pretty much to get both the monitor and mode interfaces up, and now you could do anything you'd like with it. So let's actually go back to the slide so that we can sync up with what is planned for this video. So there you go, we have the WLAN config tool. Now, depending on if you basically are using the AC Lite, AC Pro, AC HD, you might find more options available in WLAN config. For our purposes, well, all I needed was destroy and create. That is available across all the devices from Ubiquiti. So we've created the 2.4 and the 5 gigahertz monitor mode interfaces. And now let's actually go ahead and look at traffic from these interfaces. Okay. So notice that we also have the TCP dump tool on this. So the first thing I'm going to do is put the interface on a channel. So I'm going to put mon0 IW config, mon0 channel, let's say 1. And if we run TCP dump on this right now, let's make it verbose, you will see that we can find all of these different networks, beacon frames, and all of that stuff come by. Fantastic. Now similarly, let's actually set mon1 on channel 36. IW config mon1 channel 36. Okay, so now if you look at both of these, we will clearly see that mon0 is on the 2.4 gigahertz, while mon1 is on the 5 gigahertz 802.11 AC, and mon01 is NG. Okay, now similarly, we can go ahead and monitor frames on channel 36, right? Depending on if anything is actually available there or not. Keep in mind that you might be in a surrounding area which might not have too much of traffic for 36 at this point, right? Okay. Now, what more can we do? Well, we can go ahead and stream packets from this device back to our Kali instance and look at all of that using Wireshark. So let's set that up. Just going to pause the video. Okay, so looks like channel 153 in my vicinity seems to have a little bit of more traffic on AC. So as we can see, we are seeing more number of packets. So now the whole idea is, how do we stream back all of this into Wireshark or store it inside TCP dump or many of these things. So this is what we will look at in the next video, is how to stream data back into our little Kali VM, right? So that's all for this video, and we'll see you in the next one where we'll look at some of that cool stuff. Thank you.